Good afternoon or almost evening, everyone. My name is Matt. I am from Whereabouts, which is a company that was created by the founders of Apache Sedona. Quick question for the room. Who here uses geospatial data on a regular basis? Who here wants to use spatial data? It should be everyone. No, I'm just kidding. So I'm going to talk a little bit about using Iceberg for geospatial data. Our team has done a lot of work with the recent adoption of the V3 spec in Iceberg, adopting geospatial data types, which we're really excited about. I want to talk about some very specific use cases that you can use Iceberg for, specifically around time series data. We're going to talk a little bit about weather. Weather, of course, is something that's impacting all of us all the time. It changes constantly, so it's a perfect use case for that. I grew up in Minnesota, so this is actually a blizzard that I was very young, but I do remember it. So I was used to stuff like this, lots of snow and these types of things happening. This once happened when I was living there, when the whole Metrodome collapsed, which was our football stadium. There was 3 feet of snow on top of it. So these were like, weather calamities that I was used to, right? And then in 2011, I was moving to New York, and I thought things would be really great when I moved to New York, right? Who lived here around 2011, or has lived here since that time, 2011, 2012? You might remember what happened shortly thereafter. This was where I lived right outside my apartment in Stuyvesant Town during Hurricane Sandy. So my street turned into a river, literally, and it was we were out of power for several days. And then, shortly thereafter, if you lived here since 2021, you might remember these massive rainstorms that came through. This was the day before my daughter was born, so I remember it very clearly when my mother and father-in-law were driving, and they said there's about 100 cars in the LIE just parked there, just because there was so much rain. This was fall of 2023. Things like this were happening in the subway in 2024. So the long story short is, I've been interested in flooding and water and rain ever since I moved here, and how it happens, because it's a very unique type of situation in New York. We don't have, these, massive river flooding things that come through. We have stuff like this that's taking place. Now, there's a lot of different ways to look at this, and there's a lot of different types of flooding, like I said. As you can see here, the National Weather Service publishes these forecasts on a regular basis that tell you where they have observed flooding. And if you see that data, the map in the upper left corner, that's basically the data set that we'll be looking at. It's a data set of river gauges that they have across the nation that measures the height of water at an interval of every 15 minutes, right? So it's really valuable data to tell us how the rivers are going up and down, because we can also measure and get a proxy of rainfall. We can see how the water is moving through the system, all these different things. And there's a whole science of hydrology that backs this as well, because this is just one thing to look at, but it does give us a metric to understand, okay, what's taking place in a very real time. Now, the floods, of course, there are more of them, and what we call generational flooding there's increasing generational flooding taking place. So the way they designate floodplains, if you have a home and you have flood insurance, or you've ever gone through that process, there's what's called a 100-year floodplain. That's where a flood will occur every 100 years or something like that. It's very rare, but those 100-year occurrences are getting more and more frequent. So that's what we're starting to look at, and we're increasingly seeing this be an important factor. So this is one slice of a use case, if we think of it that way. This is the data that is published, and you can go to this website, I think it's water.noaa.gov, and you can see at any given point in time this map, which will tell you where rivers are flooding, and where they are higher or lower, and then it will give you the actual observed values and a forecast. You can see this is at a specific point in time when I took this I think was in April. There was some flooding in Oklahoma and down the Mississippi River Valley here. So there's high rainfall, things like snowmelt. These things happen on occasion, and there's, of course, these really catastrophic events that take place as well. So this is what you can look at. The problem with this is that there's no historical record of this data that's just made available for anyone to use, right? They basically publish the data. You can look at the map, you can see it, but you can't do some historical analysis on it, and that's a really big problem. Now, this is how the data is stored. This is how a lot of government data is stored. It's just a website where you can go and get this. Does anyone want to venture a guess what's inside these zipped up files?
Text files.
Shape files. Yeah, so who's used a shapefile before? So you know the pain of this. A shapefile is a very specific type of geospatial data. There was reasons why it was created, but it's not a great modern data type, right? It's actually multiple files. There's generally between 3 and 6 files inside the zip file, which represent the shapefile that store different types of spatial data. Over time, we've adopted more modern formats, like we've recently built out GeoParquet, which adds geospatial data to the Parquet specification. Now we have Iceberg, there's Arrow, so we're starting to catch up to make this data more analytics ready. But a lot of data is still trapped in things like this, right? And that's really a big problem that Apache Sedona and Whereabouts looks to solve, is how can we take that data and make it more modern and accessible. You can actually go to a website that tells you why you should switch out of shapefile. There's a whole list and reasons behind that. Probably the biggest reason is that shapefile is just overwritten every 15 minutes, right? If you don't get it, it's gone, right? So this is a perfect case for something like Apache Iceberg. We can actually go retrieve that data, pull it in on a very regular basis, and start to take a look at that. So that's actually something that we started to do, was actually use Whereabouts, which is basically a cloud compute platform for Apache Sedona. We can actually go and write a script to go out to that shapefile, sync it every 15 minutes, use Airflow to detect if that's changed, push that in, and pull that into this Iceberg spec. And now we get a complete historical record as it develops over time to see how that changes. Now, this probably won't sound like large data, but for our geospatial community, it is. So there's about, I think, 10 to 12,000 of these sensors that are pushing out data every 15 minutes. Some of them are updating. Some of them will skip an update or not pass data if it doesn't need to. So there's all these little things that we have to detect in there. So let's say we have a sensor. It's floating in the middle of the Mississippi River. Let's say one of these red ones here. And as you can see here, all those dots on that arc are basically an entry in that. Sometimes they will update, sometimes they will not. And we basically can take, and this is a really key piece of, I'm sure all of you know why this is important in Iceberg, but for us having it available and making it used to say, this sensor did not update, I do not need to add this record. So as I'm appending those records, I can prune out data I don't need, I can easily add to the records I do need, and I can see where things are changing and updating and have that in those snapshots and time travel. Now, we've really never had access to that type of data before, or not that type of ability to work with that data across very large analytical data sets, which is really interesting. Another thing we're starting to work on is also adopting this to different, there's 2 other primary types of spatial data, I would say. One is climatology data. So that's stored in like array-based cubes. Basically, you have lat-long grids across the entire world that measure things like temperature, rainfall, weather, and then they slice them across time. And we're adding, it's called, traditionally it's called a net CDF, but we're having a ZAR format. There's some different tools that are bringing that into an Iceberg spec. And finally, satellite imagery, which is being collected all the time, everywhere around the world. One big thing that satellite imagery can do is you can actually run these like AI models on top of that to do things like object detection. Is this a car? Can I count cars in this different area? Can I detect if there's deforestation? You can look at carbon, emissions, all these different things. So actually being able to map that into an Iceberg table, look at the time change, and then pull different features out of there is really important. So what we did, and so to sum all of this up, and I want to make sure I leave some time for question, we're catching up. We're a little behind, but we're excited to kind of have a seat at the table, basically. Cloud native formats, we're starting to optimize those for this modern infrastructure where you can read over cloud storage. GeoParquet, cloud optimized GeoTIFFs, which is a satellite data, and then ZAR, which is a modern adaptation of the NetCDF format. All of these data sets that are being publicly collected by NASA, NOAA, US or European Space Agency, and many different agencies around the world are starting to be ready for this analytics modern data stack. We're also adding efficient data pipelines where we can stream this data more efficiently, we can process it more efficiently, and we can actually see this historical record, which we really didn't do before. It was really focused on what's happening now, not how can we analyze what's taking place, and how can we predict and use that going forward. Geospatial data is coming to a point where it's another table join away you can now use with the v3 spec, I can do a simple bounding box join, right? How many things are in this box, or how many things fall within a specific state polygon? Can I count points in different features and count them up? And we can also scale by default now across time and space. So just what else do we need to do and how do we need to get there? We have these spatial formats that are coming along. Spatial catalogs are adding these different capabilities. We still need scalable support for the raster and array-based data, which I was mentioning. We're starting to try to adapt those in using some different specifications that those communities have developed, such as a spatiotemporal asset catalog, which is a cataloging service for satellite imagery. And then how do we get the cloud native tools speaking that data language, adding spatial SQL compatibility into the query engines and things like that. So finally, just to show you what this full thing looks like, this is a very high-level architecture diagram. We can take that shapefile, we can detect and overwrite find the overwrites every 15 minutes. I have Airflow dump that data into S3. I create a few different tables so I can actually read that in as a shapefile using Sedona that pulls it into a Spark data frame. From there, I can do some different analysis, figure out what changed, what didn't, drop the data I don't need. It scales up to about 350 million observations annually, so you're getting a lot of rich data about how things are changing over time. And then I can run some spatial statistics on top of that to run what's known as a Geddes or GI star analysis, which is giving me hot spots and cold spots analysis to see where there is a cluster of flooding, not just maybe a sensor that's malfunctioning or something like that. I can find the spatially significant areas within that. So that's kind of the full project we developed. We have this full pipeline and piece it together. And long story short, I think we're really excited to have spatial compatibility now brought into Iceberg. So as v3 spec gets adopted, make sure to use some spatial SQL. And yeah, that's my talk.
Any questions? This is as real life as it can get.
Yeah.
Right.
I mean, looking at the initial 2012 scenario versus what happened just recently last week in Texas, where do you think our technology is lacking right now in real-time assessment and disseminating preparedness or whatever? Like whatever you just showcase seems to be addressing the problem, but I don't know where. I mean, if you can just throw some light. I mean, what could be going wrong or what we can do to avoid it?
Yeah, specifically looking at what took place, the tragedy in Texas, there's two things that you can look at. One is that those sensors picked up that information, right? It could see that there was a rush of water coming through. Now, how those things translated into alerts, that's beyond my knowledge of how that part of the world works, but that you can go and actually look at the data. It's still out there on this website. You can see this massive spike that's coming down the river. The second is that FEMA publishes these floodplains as, again, shapefiles that are made publicly available. They're incredibly complex geometries because they're used to determine very specific boundaries of floods and changes like that. You can actually look at all of these different buildings and things that fall within the floodplain. And I believe some of the areas were impacted. If you built before the floodplains were released, you're kind of grandfathered in. You could be in a very high-risk flood area, but still have a building that was built. So what can you do is we want to bring more of this data out into other systems and make it readily available for people to start to use. In terms of like government responses and things like that, that's beyond the scope of what I know that's done. But that data's there and it should be used and yeah.
Very good. Thank you.
Yeah.